Hey everybody, it is Mr. Zabo, and I am coming to you today with some review of some linear programming. We're going to do one problem together. It might get a little clumsy from time to time as I try to switch back and forth from the notes here to Desmos and show you guys some graphs and how we type this stuff into Desmos and how we can use that to come up with our graph. So bear with me and take some notes if you can. So, to save some time, I have gone through already and highlighted and underlined some of the most important pieces of information in that word problem. I would highly recommend you start these problems this way by understanding these things. What are the numbers saying? Where do they all represent? What do they all represent? And how am I going to define my variables? We've mentioned this in class. We've talked about this. Defining your variables is typically coming in the last sentence or in your question. Not always, but typically. In this case, it says, find the number of large and small Thanksgiving baskets they should buy. Those are the two pieces of unknown information. That is how we're going to define our variables. So we have to define them by saying we are going to let x equal one of them and let y equal the other. How you define this is going to change what your graph is going to look like. On mine, will define that x is the number of small baskets and that y is the number of large baskets. If you switch that around, your graph is going to look different, and that's going to be my job to take a look at and make sure your graph matches how you have defined your variables. That's why it's so important that you define them. I need to be able to follow what work you're setting. That is also telling us that this is a maximized profit. So write the max or min equation. It's a maximized profit equation here. This part's a little bit trickier because in the word problem, they have not specifically given us what the profit is for the small baskets or what the profit is for the large baskets. What they told us was that small baskets are $10 to buy and they're selling them for $6. It's our job to interpret that. Since we are selling them for $6 and buying them for $10, we are making a $6 profit on small baskets. And then interpret large baskets. We're buying them for $15 but selling them for $25. We have to interpret the profit there as a $10 profit. That is going to be how we come up with our profit equation. It's going to be $6 times x plus $10 times y. Again, let me repeat that. It can't be 10 or 16 with the x because we're buying for 10, selling for 16. 16 is not the profit. The profit is the difference between what we spent for it and what we are selling it for. Okay, now we're going to list our constraints, and that's what I have highlighted in blue. Okay. They cannot sell more than 100 baskets. So that's going to be a constraint where they are selling less than or equal to 100 baskets. We've defined baskets as x and y. That's a sum. X plus y, selling small baskets plus selling large baskets, has to be less than or equal to 100. And they can afford to spend up to $1,200. So up to is another less than or equal to $1,200. Now spending is going to go back to what we have highlighted in yellow up here. We are buying small baskets for $10. So we are spending $10 on a small basket, and we are spending $15 on a large basket. So in this case, it's going to be 10 times x plus 15 times y. So my two inequalities I get from the word problem come from a combination of these numbers up at the top and the idea of selling versus profit. There are two implicit constraints in here that we should list as well. We cannot sell less than 0 small baskets, and we cannot sell less than 0 large baskets. So our implicit constraints here are x is greater than or equal to 0 and y is greater than or equal to 0. Okay, from here, we're going to want to graph those constraints here. But it's not been labeled for you at all. You're going to have to figure out how to do that. Desmos is the key. So go ahead and open up Desmos in another window if you want. You can pause the video and go open up Desmos. I've already got mine open and I'll show you. You do not have to solve for y when you put this into Desmos. X plus y is less than or equal to 100. 10x plus 15y is less than or equal to 1200. The less than or equal to's are going to be in the keyboard down here. And we can hide that. I have mine just centered. I have it at the home. Well, this is not showing what I need us to see. So we can zoom out. I just keep zooming out and I start to see the picture I need. Here's my overlap. I didn't put the constraints x is greater than or equal to 0, y is greater than or equal to 0. Because remember, those constraints just represent quadrant 1. So when I go back to my Desmos, I can go ahead and just center it over onto quadrant 1. Okay. I might want to make it a little bit bigger so I can see and focus only on quadrant 1. Now this is the key pieces of information that I want. As I get this centered again and I look at my graphs, I can come up with, I need to get to 120, 0 on my x-axis, and that line will also go through 0, 80 on my y-axis. So here I can figure out what I want to count by. I know I have to get to 120 and I have to get to 80. My other line is at 100 and at 100. Well, that to me screams count by tens. Okay, so on here, I'm going to make each value worth 10. 10 and 20, 30 and 40 and so on. So now I've been able to figure out my scale by using Desmos. I've labeled my x and my y-axis. I'm looking only at quadrant 1 because of my implicit constraints. The rest is graphing my lines. Well, I already know I have 0, 80, and that is my blue line, and it's going to go and connect to 120, 0. It's a solid line, and I'm going to start at 0, 100, connect to 100, 0 with a solid line for my second inequality. So I go back here and we graph those. Now our lines are in there, we have to come up with the shading. So we'll go back and look at Desmos. Hopefully we see the overlapping, but again remember we can change this to see the overlapping a little bit better. We know this is shaded all the way down here. This is shaded underneath. So where are they both shaded? We see this heavily shaded in, slightly discolored area. That's going to be our solution set. So we come back in here and we can continue or finish our graph by shading in the proper solution set. And I'm not going to have it shaded in perfect, but you guys get the idea. That's where the solution set represents, and I'm going to try not to go over the lines like I did here because that is another constraint here. We have to stay in quadrant 1. So the last part is going to be identifying all of our ordered pairs that represent the borders here. So in orange here I've highlighted the vertex of these overlapping region, our feasible region. And there are 4 of them, 0, 80, 0, 0, 60, 40, and 100, 0. That's going to represent where we can minimize and or maximize this function. And if we want to confirm that that's where it is, again, we can use Desmos to confirm that. 60, 40, 0, 80, 100, 0, and we know the origin is going to be our second or our fourth vertex. So now I'm going to take each of those vertices, which represent my x and my y, or my small baskets and my large baskets, and substitute back into my profit function, which was 6x plus 10y. Plug each of these into that profit function, and we will identify the minimum and the maximum profits. So we see here at 0.80, it's an $800 profit. At 0.0, there's no profit. 60.40, there's a $760 profit, and 100.0, there's a $600 profit. So the 0.80 is my maximized profit, and 0.0 is my minimized profit. This is a problem where they asked us to find the maximized profit. We just saw that that's at 0 for X, which we defined as small baskets, 80 for Y, which we defined as large baskets. So we would have 80 large baskets and no small baskets, and our maximum profit would be $800.